Hello again, YouTube. I'm going to have another look at this LED tester that Big Clive sent me as a prize or a gift. Um, it's a pretty simple tool. You put an LED in it and you press a button. So we've got an LED here. Put an LED in, press the button and the LED lights up. You've got a range along the top here. You've got milliamps, you've got the polarity shown here, and then at the bottom you've got this tester for a 4-pin or a 6-pin LED chip, and that basically works. You can see over the end here it says ACA, and here it says CSE, so that's anode cathode anode or cathode anode cathode. So that's for the little chip type. I don't have any of these to test, but I've got lots of standard LEDs that I can test. So just going to have a quick look at this device, and I was also going to have another look at some of the LEDs that Clive sent me. So I've taken the back off of this just to let you see what's inside it. It's pretty straightforward. Got a 9-volt battery. The battery itself has got a clip, comes down to here, that goes through this push button. The push button energises the circuit. There's an LED here, lets you know when it's active. There's a little resistor for the LED, and then that goes out to the output leads. So that's all that's on that board. It's pretty simple. You've got 2 fly leads come from this little board up to the top board. They come in up here, and then you've got a couple of common rails. So you've got, if you have a look along the bottom here, you've got one big common rail, and you'll notice that a couple of the solder joints have bridged out. It doesn't matter because it's a common rail. That common rail also comes up to here, and it's also bridged all the way along. Again, there's a couple of pins bridged out. Again, it doesn't matter. So they're the bottom row of the LED testers here. So that's minus the negative or the 0-volt. And again here, these are the 0 volts. And you can see that down here, the way the arrangements work, you've got sets of 3 pins. So you've got all along the bottom will be negative, but they'll be bridged up to the top. They'll be bridged round here. Actually, you've got some resistors round here, and the resistors here will go to the positives or the anodes. Up top, the top row, the standard LED, that's a simpler way of looking at it. You've got the minus, the negative along the bottom. Along the top you've got all the positives, and then above it you've got a row of resistors. So for each set of holes, each one of these has got a different resistance value, and based on a 9-volt input, it'll then drive the LED at this milliampere rating. So it basically restricts the current. So you can take your LED and pop it in an appropriate resistance value for your LED. So that's pretty much it. It's pretty straightforward. I'm not going to take the board out because there's nothing else on the back of it, and it would just misalign with the little plastic risers. So there's not much point in doing that. I'm just going to pop the back on it. Okay, and that's it back together, ready to test again. Well, you might notice my workbench is a bit bright here. I've got an extra lamp right above the workbench. It's just a 12-volt LED, an MR16 style LED, but I'm driving it off of a 12-volt battery. The reason I'm doing that is so that I'm not introducing any noise from switch mode supplies or anything like that. But the reason I've got the bench brightly lit is I want to have a look at one of these LEDs that Clive sent. Now this is a multicolour LED, and if I pop it into the tester, you'll notice it starts off red and then it gradually goes to green, then to blue. I think this might actually be a little bit swamped out. Let me see if I can bring the exposure down. It goes to cyan, and nice purple magenta colour. The way this works is different to normal or standard 3-chip LEDs. So this is a 3-chip LED. I've got a bag of these, I think got them from eBay or Amazon. And you've got one long pin, which is the cathode, and then you've got 3 shorter pins, which are the 3 anodes. So if I was to drive this, you drive the pins individually. So let's just pop that in, and by driving this pin, it's red, and you see it stays red. If I choose a different pin, well, choosing a different pin is going to be difficult because they're not lined up properly for the tester. I would have to bend these round, but you get the idea. You apply your voltage to this pin, will be red, one of these is green, one of them's blue. So to use this as a proper 3-colour LED, you need to have some sort of microcontroller or some sort of slider device. So an Arduino is ideal for that, but they're okay, they're pretty useful, especially if you just want to give a status colour. So you see, let's say you've got a device that's running and you want it to be green and then go red when there's a fault, then this is the ideal LED for you, because you can then just turn off one lead, feed the other lead, and you can get multiple colours out of the one device. You can overdrive these, you can burn them out easily if you don't use them with a resistor. So it's basically 3 standard LEDs inside one package. Okay, so I want to take a look at Clive's LEDs again. So these are the LEDs he sent me. They're 3-colour, or they're multicolour. They've got 3 chips in them, usual red, green and blue. They've got it all in the one package, but they change. It's a colour changing LED. It changes colour on its own, and between colours it pulse width modulates. So effectively get short pulses of red and short pulses of blue together will give you a purpley effect. But it's not just the LEDs coming on and off, they actually pulse, so something is controlling that pulse, and it's not just a little transistor. There's something inside this making logic decisions and driving the outputs. So to be doing that in a package this size is pretty impressive. So to try and get a better look at what's going on inside this, I've taken one of the LEDs and I've cut the top off with a Dremel, and then I've polished it as smoothly as I can, and I've used a carpenter's honing block and some oil and polished it as highly as I could, to see if I can get rid of some of the opaque frosted plastic. So we can maybe see if we can see the chips inside here. What I've also done is I've managed to avoid the bond wires, so if I bring this on, you can see it still works, and there you can probably see there the flickering between the colours, and that's the pulse width modulation, changing the colours. And that's the smart bit. That's what I was wanting to try and have a look at. Okay, so what I'm going to try and do here is I'm going to put a magnifying lens onto my camera, and I'm going to apply a bead of isopropyl alcohol to the top of this, because it's not quite as clear an image as I would like. So when you put a drop of isopropyl on here, the isopropyl is very pure and it forms a bead on top, and it gives you a very it's like a lens basically. It dries up pretty quickly, but we can always apply another bead if we want to have a closer look. So let's give that a go. Okay, so I've just applied applied a drop of isopropyl, and I think you can see reasonably clearly. See if I can centre this. You can see some fibres floating about in the isopropyl, and it's moving about because the isopropyl is evaporating. Okay, so I'm just I've applied a little bit of isopropyl. I'll try applying some more. There we are. Okay, so now you can see up the top of the image, so the square metal bar, that's the anode coming up from the pin. So that'll bring the voltage up. And the first wire, the bond wire that comes off the anode, goes to the processor. And then from the processor, you can probably see there are 4 distinct wires coming off. There might even be 5, I think it's 4. Now the reason there's 4 is the larger plate, the anvil, that's the cathode. So the wire to the far right looks as if it's coming off and going straight to the anvil, and that's basically power for the processor. And then you've got the 3 colour chips, and they've got a bond wire each, so that microprocessor is driving each of the colours individually. And that's why what I found with this chip is that you can put it directly onto a power source as long as the voltage isn't too high, and it will work without a resistor. Now I wouldn't recommend that you do that long term unless you get the data sheet and calculate the current properly. But the fact that it's got that microprocessor, the processor itself is doing some current limiting, and that's pretty much it. But if you think about the size of this thing, the image you're looking at, that's what, 5mm across. It's not even that. I don't think that's 5mm, isn't that's the length of the head, I think, I'm sure. Like that, yeah. So the image across is about, I reckon you're looking at 2.5mm there. So the anvil in the middle is less than 1mm, and you've got 3 LED chips and a microprocessor going on in there. That's pretty impressive. So it might just have seemed like a bunch of LEDs that Clive sent me, but it's one of the most interesting things I've received in the post in a long time, and it's been a lot of fun trying to chop it open. I've tried to cut a few and lost a couple because the heads have come off, and when I've managed to cut down far enough, I've actually gone right through the bond wires, so they didn't work anymore. But let me just, without jumping around too much, there you are, you can see, wow, you can definitely see the pulse width modulation there. You can see the blues off to the left, and there we've got some red and some green together, and some blue. So it's a very, very impressive little piece of kit. The amount of the engineering that goes into these, and to think that you get bags of them for, you know, a couple of quid, it's just mind blowing. You know what comes out factories nowadays, especially what's coming out of China. The quality of an awful lot of the stuff's really good. But you know, when you see this, when you see the level of detail involved here, that's pretty impressive. So thanks again to Clive for sending me this piece of kit and these fantastic little LEDs. That was really, really interesting, trying to take one apart and get to look at the component inside. Had a lot of fun doing that. I'd spent a couple of hours fruitlessly attempting it, but got there in the end. If you haven't seen Big Clive's channel, I'm sure anyone who's seen my stuff will have seen Big Clive, but if you haven't, Big Clive, look at his website, bigclive.com, and support him on Patreon. He does the most interesting technical teardowns, modifications, and he just takes stuff to bits and has a good look at it. And it's the YouTube channel and the Patreon channel that I spend most time watching. So I strongly recommend that you go and have a look at Clive's channel. Thanks again for watching my video. If you did like this video, then please like and subscribe. I'll see you again.